Okay, so guys, today I will start your SD-WAN OMP protocol or overlay management protocol. So we will see in and out of OMP how the things happens on OMP, basically how your WAN routers and your vSmart controllers take the help of your OMP protocol to send these particular routing details and all these kind of things we are going to discuss today. So there are so many things on OMP, but I will try to cover many. Whatever left, I will basically try to make some videos on that. Okay, so guys, just confirm yes no on chat if I'm audible properly or not. There is any echo, just confirm on a chat. Okay, that's great then. So guys, first of all, you have to know OMP. OMP stand for Overlay Management Protocol. What is the meaning of this Overlay Management Protocol? Overlay Management Protocol is that if I'll go into my topology here, in this topology, you will see this particular area is my underlay. The main job of this underlay is to provide the connectivity between your sites, right? Between your managed routers, which we have on your sites, on your head office, and this underlay will also provide the connectivity till your controllers. Now, your OMP, what it used to do, your OMP is running between your managed routers and your vSmart controllers. And also your OMP is running between your vSmart controllers basically. And guys, this OMP data, when this particular routers, if he wants to send any kind of information to your vSmart controller, what it will send via OMP update. It will send via OMP update basically. Okay, so now, so guys, in your interview, what they used to ask, your OMP protocol, it is running between your V's routers with the vSmart, or they will try to misguide you, right? Can we run OMP between these two VNS routers? We never run. OMP runs between this VNS routers and your this vSmart controller, and between the vSmart controller. Maybe they will try to ask here basically, this VNS router, if he wants to communicate with your vManager, how it will communicate? It will communicate via OMP or not? So they will ask such kind of questions, okay, in the interview. So you have to remember this thing, guys. Your OMP is always running between your vSmarts and between your vSmart controller and your VNS routers. Now, OMP is a TCP based protocol basically. And remember one thing, if you remember, if this VNS routers, when he will communicate this vSmart controller, right? So here you will see we have a two transport. We have here two transport. One is MPLS and another one is internet, right? So what it used to do, it used to create a DTLS tunnel, right? With vSmart through both the transport. Now, when after creating these DTLS tunnel, okay, with your vSmart, what used to happen? Your OMP peering is created between this Dubai router and your vSmart one, between your Dubai router and your vSmart 2. And guys, always remember, let's suppose you have here 3 vSmart, like you have one more vSmart 3. So by default, this Dubai router will make the OMP peering with 2 vSmarts only. This is the default behavior, guys. We can able to change this behavior, okay, but this is the default behavior, just remember. And guys, when they will create these DTLS tunnel, your OMP data, OMP updates can go via this tunnel, can go via this tunnel as well. So now whatever data you will send via as a OMP updates between your VNS routers and your vSmart controllers, it is secure, guys. It is going in a secure way through your DTLS tunnel, and your DTLS tunnel will take care of the CIA, confidentiality, integrity, and authenticity. Just remember. And guys, just remember one thing. Your OMP protocol is not running between your VNS routers and your vManager. No. Your OMP is not running between your VNS routers to VNS routers. No. OMP is running between your vSmart 1 and between your branch routers. That's it. If I'll go here in my Dubai router, if I run this command, so control connections, we have control connections, right? We have a control connections here. These control connection is created with both of your vSmart controllers, right? And also one more thing here. If I run this command, so OMP peers, you can able to see we have a peering with the both the vSmarts, right? We don't have any peering, OMP peering between your Dubai router and your London router. No, Dubai router just have a OMP peering with your vSmart. But if I'll go into my vSmart, if I run this command, so OMP peers, now this vSmart basically, vSmart 1, it is having the OMP peering with vSmart 2. This is the IP address of your vSmart 2, and it is also having the OMP peering with your head office, with your Dubai office, with your London office, then Tokyo office, and your New York office. It is having the peering. So this is how your OMP peering is created. Basically, just remember one thing. If I'll go into my vSmart 2, I run this command, so OMP peers, you can able to see the OMP peers basically here as well. vSmart 2 has a OMP peering with vSmart 1, 99.99.19.12 is a system IP of your vSmart 1. And guys, always remember, your OMP peering is created with the system IPs. With the system IPs, right? Your OMP peering is not created with these interface IP. No, it is created with the system IP. Just remember, OMP peering is created with the system IP always. Just remember. Now, so now let's try to understand here. So your OMP protocol is used for exchanging the control plane information, which is your routing updates between your VNS routers and your vSmart controllers. Now, what it used to do, they use this OMP protocol for exchanging the routing updates between your VNS routers and your vSmart controllers. Which means if you will see here in our topology, on this topology, we have these routes. We have these routes. Now, this routing information, these routers, what they will send to your Dubai router, this is your VNS routers. And after that, this VNS router, it will send these routing updates to your vSmart controllers. Same thing done by the London router. Your London router will also send the routing updates to your vSmart. If you want to see that detail, if you will go here into your vSmart, if you run one command, which is so OMP routes, if you run this command, you will get this type of output, guys, where you will see there is a one route which is 172.16.60.0/24. This is your Dubai branch route, right? This route is received from 99.99.1.3. So I will discuss this part in a while, guys. Okay, so what I can do, let me just, if I run the command in this way, don't worry, we will discuss in details everything. So if I'll pick one of the route here, which is 172.1671.100. Now this route I have received from two devices here. What are these two devices? I have received one same route from your vSmart 2, and I have received the same route from your London router. Because all your routers, what they used to do, they used to update their routing details towards both the vSmart controllers, vSmart 1 and vSmart 2. And after that, these vSmart, they will also exchange the routes with each other. That's why we are able to see here same route from two devices, one coming from London branch and another coming from vSmart 2, because right now we are running this command on vSmart 1. So if you will run this command, so OMP peers, generally in this command, if I'll pick the peer which is 60, 99, 99, 99.60, which is the Dubai router, right? This is the site ID of your Dubai router. Right now, OMP peering is an up state. This is the uptime. And after that, you can see here from Dubai router, what I have received the 8 routes. What are these 8 routes? If you will check in your Dubai, I have these 4 routes, right? What these 4 routes, he has updated to through MPLS and through internet, which means that's why it is telling here received the 8 routes basically, because same 4 routes he received through MPLS and same 4 routes he has received through the internet, guys. Just remember. Now apart from this, so this statement is true, guys. These devices, your VANIS routers, they will send the routing updates or routing details to vSmart. They never exchange the routes with each other directly. They never exchange these routes directly with each other. No, this is not possible. They only send these routing updates to your vSmarts. Because why they are not sending the route directly? Because they don't have any kind of peering, right? They don't have any kind of peering here. So that's why they are just sending the routes to your vSmart. And when your vSmart receive these routes, what it used to do, it basically runs one algorithm. That algorithm is OMP path selection algorithm. But when he receive these routes, he will run these routes through the OMP path selection algorithm. And after that, he will calculate the best path. And after that, he will basically update the routing details towards all your VANIS routers. So your Dubai routes, these routes, when this vSmart 1 or 2, they will send towards London router. What? After basically calculating the best path, they will update to the London router. They will update to your Tokyo branch. They will update to your New York branch. That is the reason if I'll go into my London router here, this is my London router. If I'll go into my London router, if I run this command, so OMP routes VPN1. I want details on tabular format, and you will see I have received basically this route 172.16.60.0, 61.0, 62.0, and 63.0. Who is the updater? From where I got these routes? I got these routes through my vSmarts, right? You can see this is the vSmart IP address, right? And also, which device is owning these routes? You can see the TLOC IP address of that route. These routes belongs to your Dubai branch, because we can see your Dubai branch having this particular system IP address. You can check it out here. 99 99.99.60 is a Dubai router system IP address. So that's how basically they used to exchange the routings basically. Your managed router, just remember, always update these routing details to vSmart, and vSmart will update these routing details further to the other devices. DNS, who is this guy? DSN? Can you just hold? Let me just complete the topic. You are just asking me the questions which I'm gonna cover basically in the future things. Okay, so do not ask these kind of questions. Okay, please. Guys, now I'm not looking for the chat. Okay, because I'm not looking on a chat. Okay, let me just go through with the things now. OMP runs between your V's routers and your vSmart controllers, and between your vSmart controllers themselves, right? This thing we have already seen. OMP is a TCP based application. It is similar to BGP. So OMP is a TCP based protocol, guys, just remember. OMP is a protocol responsible for establishing and maintaining the Cisco SD-WAN control plane information, guys. It is used for path selection, loop avoidance, and policy implementation. What is the meaning of that statement? So guys, your OMP protocol is used for which path they will follow. Basically, what it used to do, it used to basically sends you the exact details, basically exact routing information. If this London managed router wants to reach out to this subnet, what this OMP will help you, OMP will provide the exact details how he can reach till this particular machine. So your routing detail is taken care by the OMP protocol. OMP will also exchange the policies. If you want to control anything, if you want to apply the security policies, this kind of information is also sent by the vSmart controllers towards your VNS routers via OMP. Your IPsec parameters, because by end of the day, this VNS routers will create a IPsec tunnel or either GRE tunnel, right? Whatever the encapsulation we are using, but in our case we are using IPsec. They will create a IPsec tunnels, right? So in IPsec, you know, there is a phase 1 exchange, phase 2 exchange, right? They will create a session keys and all, right? There is an encryption algorithm, hashing algorithm, all these details they have to exchange, right? So what? But in your SD-WAN, they are not going through this phase 1 and phase 2 exchange, because your vSmart will help you with that detail. He will send all the IPsec related parameters to create IPsec tunnel. This is the meaning of that statement, guys. Now, when is learn the prefix of another site through OMP. This thing also I have told you guys, right? This WAN is routers. We'll get these routing details of Dubai routes, your Tokyo routes, your New York routes via OMP, and vSmart will send these routing details. Okay? Because vSmart will get all the routes here. It is enabled by default in SD-WAN fabric, guys. And now just remember one thing. This OMP configuration we don't need to do by ourselves. Let me just give you one more example here. Let's suppose I have one setup. Let's suppose I have this kind of setup. I have my R1 router, I have my R2 router, then I have R3 router, and after that I have some PCs here and some servers here. Now if this PC wants to reach to these servers, and let's suppose we have decided to run OSPF here, which means we have to do the OSPF configuration on this router, OSPF configuration on this router, and OSPF configuration on this router. But in your SD-WAN, we don't need to do any kind of configuration with regards to OMP. It is already done for you, basically. It is by default configured. You don't need to do it, basically. Now, so your OMP is enabled by default in your SD-WAN fabric. Once we start up the vSmart controllers and manage routers, it is not necessary to explicitly configure or enable the OMP protocol. These devices automatically initiate the OMP peering session between themselves, and two IP endpoints of the OMP session are the system IP. So guys, the meaning of this statement, your OMP peering is always created between the system IP, not between the interface IPs, guys. If I'll go here, if I will run the EIGRP between these two routers, then when EIGRP neighborship is created, that neighborship is created between this IP. Let's suppose we have 10.1.1.1 here and 10.1.1.2 here. That time EIGRP is neighborship is formed between these two IPs, right? But you're in OMP, your neighborship is formed between the system IP. So that is the reason, if you have a multiple transport, like in our topology, we have a multiple transport, right? We have one through MPLS and one via internet. Doesn't matter if this link goes down or this link goes down. Not doesn't matter, because your OMP will relay from here. It will start sending the updates from this link. If this link goes down, then it will start sending the updates from another link. It just need one transport, guys. So just always remember, your OMP peering is created between the system IP. That kind of benefit you will get, basically. Now, coming to the next one, the router peers only with the vSmart controller. So guys, your OMP peering is created between your managed routers and your vSmart controller. Your managed routers, they don't form any kind of OMP peering with each other, guys. OMP peering is always created between your vSmart routers and your vSmart controller. Just remember, vSmart routers don't need to form a routing adjacency between themselves and do not have to respond to an excessive number of routing updates. Let me just tell you basically this statement in a proper way, so you will get some idea. Let's take an example here. Let's suppose I have some router. I have router R1. I have router R2. I have router R3. I have router R4. And here also I am having some router like R5, R6, R7. And here I am having one switch. And they have a connectivity like this. Now behind this switch, let's suppose I have one subnet which is 10.1.1.0/24. It's 24, guys. And behind this router, let's suppose I have some PCs, like PC1, it is in 20.1.1.0/24 subnet. Now, and let's suppose they have a connectivity like this as well, just for the backup purpose. Now think here, guys, let's suppose if this interface goes down, or let's suppose this interface goes down at the switch end, or this interface goes down at the switch end. What used to happen in this particular topology? They used to basically send lots of routing updates with each other. They used to run the algorithm again, right? They used to run the algorithm in case of, let's say, OSPF. They used to run the SPF algorithm every time when there is a change with the routing. If there is this interface goes down, what will happen? There is a huge change on the topology, right? So guys, when there is a link down, or let's suppose link flap issues, or any new routes we have added here, what used to happen in that case? All these devices, they needs to calculate the path. They have to go through with the SPF algorithm. They have to calculate the exact topology, or I can say exact routing table, right? Of forwarding information base, FIP table every time. But in your SD-WAN, they don't need to create a peering basically with each other. This is the simple example with the routing. But guys, if I'll go through with one more example here, let's take one more example here. Let's suppose I have this kind of setup. I have R1 router. This is my internet cloud, which is INET. And let's suppose I have MPLS cloud as well. I have one router here R2. I have one router here R3. And I have one router here R4. Like that, I am having around 1,000 branches. They have a connectivity like this. They have a connectivity like this with your branches, and you are running, let's suppose, DMVPN here. We use this DMVPN to basically send the multicast routing traffic, which means we can send the routing update. Let's say we are running OSPF here, we are running OSPF here, we are running OSPF here as well, and OSPF here as well, right? Now, let's take an example. If this link goes down, what used to happen? Or this link just flapped. In that case, if you remember, basically, now all these routers, all these 999 routers, right? 999 routers, they needs to basically make the neighborship again with this router, which means there is a huge routing updates in your network. So guys, in your SD-WAN, this problem is solved in your SD-WAN, because if there is any link flap, if this link goes down, what will happen? If this link goes down, your OMP will go through this interface. Even though both interface goes down, is these things affect? No, because they don't care about it. Only your vSmart will affect basically. So that kind of benefit you will get in your SD-WAN. They don't need to maintain the neighbor table basically. They don't need to maintain the neighbor table. They don't need to maintain the topology table basically. Or I can say your RIP table, your routing information base. This is here, this base is maintained here. If anything happens, if these routes become unreachable, right? What? These vSmart will update that detail to all your routers, all your branches. This router don't need to do anything. So this kind of benefit you will get, guys, in your OMP. Now, all of this makes OMP more manageable, because this manageability of your OMP is very easy, because it will support such kind of things, because there is only one peering with the vSmart controllers. That's it. It is secure because all the data we are sending through the DTLS tunnel, which is secure. Here you can use TLS as well. You will get that option. And it is more efficient in comparison to the traditional routing. And guys, it is more scalable. This is a more scalable solution. Scalability was the problem in your DMVPN. The vSmart controller makes all your routing computation for the overlay, and OMP propagates this information across the fabric. Your managed routers, they just send the routing updates to vSmart. Now vSmart will do the routing computations. It will calculate the routes. It will calculate your forwarding information base, this FIP table or your routing table. And what it will do, once routing table is created, it will update these routing information via OMP updates to your routers. So that is the main thing. If you will add new managed routers into the SD-WAN domain, it will not affect the performance of the existing managed routers. It will not affect. Let me just give you one more example here regarding the scalability. Let's suppose we have a setup, this type of setup. In this setup, already this router R1, he is maintaining, in case of 1000 routers, it is already maintaining 999 neighbor table, right? It has a 999 OSPF peering with all these routers. Let's take an example. Now, if we are decided to add 10 more routers. 10 more routers, what will happen? Now, all your routers, they have to increase the things, right? Now, their OSPF peering will increase on all the routers. It will affect the entire fabric, basically. So that kind of problems you will face generally in your traditional routing, and that kind of benefit you will get in your OMP. Okay. Let me just clean it a little bit here. Okay. Now, vSmart controller make all the routing decision. This thing we have already seen. Now, what is the main responsibilities of your OMP protocols? So your OMP protocols will help you in your SD-WAN fabric for distribution of your transport locators, T-lock routes. What is this T-lock routes? I will come in a while on these, don't worry. Distribution of your V routes. What is this V route? In this topology, you will see we have these routes. When these routes sent by this Dubai routers towards vSmart, these are the V routes basically, or your OMP routes. These are your V routes. Now, go here. Distribution of service chaining routes. Distribution of data plane security parameters. So guys, just remember these things. If somebody asks what type of information is carried by the OMP protocol, so you have to tell your T-lock routes, your V routes or your OMP routes, your service chaining routes, and your data plane security parameter. These are your IPsec parameters. Encryption algorithm, hashing algorithm, VPN levels, crypto keys, encryption key and hashing key, distribution of data plane and application aware policies. So these are the things which is basically carried by the OMP protocol. It will update that information towards your managed routers. That's it. This is the main responsibility of your overlay management protocol, guys.